I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos and putting excellent comments. Thanks for your suggestions. Based on that, we have this particular video where we have 25 questions based on power rule. Practice makes you perfect, and that's the whole idea. Power rule is quite simple. Y equals to ax to the power of n. If that is the function given to you, then the derivative of this function dy dx is equal to n times a x to the power of n minus 1, which can also be written in prime notation as y prime equals to na x to the power of n minus 1. You can always pause the video, check your solution with my solutions. That will help you a lot. In case you want to learn directly from me, send an email on globalmathinstitute@gmail.com. Our students follow this success path and achieve great results. Let us take these questions one by one. First, let's have a look at these sets, right? So 25 questions I said, first 9 of them are there for you. And here is the second set of questions, 10 to 17. And then we have third set of questions where we have alphanumeric examples. Now, let us look into the solutions of these one by one. I would like you to solve them as we move along. So the very first one here is y equals to x to the power of 5. Apply the power rule. The derivative should be equal to 5, which is the exponent, times x to the power of 5 minus 1. Let me rewrite like this, which should be 5x to the power of 4. Is that clear to you? Simple as that. Well, if the exponent is negative, as in example 2, in that case, what do you get the derivative as? Well, it is minus 3 is the exponent. So minus 3 will be multiplied with 3. And this exponent will be minus 3 minus 1. And so what you get here is 3 times 3, 9, with a negative sign, x to the power of minus 4. It is a good practice to write this with 9 divided by x to the power of 4 with positive exponents. So this is also very important when you write down the answers. Next one here is again with negative and negative exponent here. In this case, what do we get? Well, the derivative now will be negative 1 times negative 3 over 4 x to the power of negative 1, right? So that gives you positive 3 by 4 x to the power of minus 2, or you can write 3 by 4 x squared. So I hope that helps you to understand how the power rule can be applied for these simple functions. Next one here is pi over x squared. Well, sometimes you may rewrite this as pi x to the power of minus 2. It helps, right? And then the derivative as minus 2 pi x to the power of minus 2 minus 1, which is minus 3. Or you can write this as minus 2 pi over x cubed. Makes sense? Pi is a constant, and therefore it should be retained as such and treated like any other number. Now we have y equals to minus 3 square root 5 and x to the power of 5, which is in denominator, will be x to the power of minus 5. So the derivative is what? Minus and minus, when you multiply, it becomes plus, and 5 times 3 becomes 15. So I could write 15 square root 5 x to the power of minus 5 minus 1, which is minus 6, or 15 square root 5 divided by x to the power of 6. Makes sense, right? Here we have square root. So the derivative is going to be what? Let me rewrite the function as y equals to square root 2 times x to the power of minus half, since it is in the denominator, and therefore the derivative is going to be square root 2 times minus half times x to the power of minus half minus 1, which is minus 3 by 2, right? When you take it to denominator, it becomes 3 by 2. So I could write this as negative square root 2 over 2 x to the power of 3 by 2, right? So, which is, let me write 3 by 2 this time. Okay. So that is how we could write the solutions of these questions. I hope first six are clear, right? Let's move on to take the next set of questions. Well, in case you have any difficulty in understanding, feel free to send an email. I'll definitely help you in this regard. Now let's get to the second set of questions where we have y equals to 2x cubed minus x. So we have a function with more than one term. Well, derivative now is what? We'll apply the sum and difference rule, right? With the power rule. So 2x cubed derivative will be 6x squared and derivative of x is 1 minus x will be minus 1. That becomes our answer for the first case. Second one, y equals to, let me rewrite this as x to the power of half plus 3x, okay? So the derivative is going to be half times x to the power of half minus 1, which is minus half, plus 3, right? Which you will rewrite as 1 over 2 square root x plus 3. So do you see? The derivative of square root x is 1 over 2 square root x, right? Good to note. Sometimes you can write this directly. Perfect. Now we have question number 9, which is y equals to 6 times x to the power of, see, 2 is the exponent and 3 is the radical, right? So it is 2 over 3, right? So you could rewrite this as x to the power of 2 over 3. And now the derivative will be 6 times 2 over 3 x to the power of 2 over 3 minus 1, which will give you as 12 divided by 3, or you can say 4, right? X to the power of minus 1 over 3, or we can write this as 4 over cube root of x. Is that okay? So in the radical form, we could write it like this. Perfect. So I hope this is absolutely clear. Let's now move on to the next set of questions. So they are becoming slightly more difficult as we move along. Now we have three different terms. Question number 10. You can always pause and then answer the question. Well, in case you need any help, feel free to send an email on the address given or visit my website globalmathinstitute.com. Let us solve these questions. Y equals to 2x minus 3 over x cubed plus 1. If you want, you can rewrite the question as y equals to 2x minus 3x to the power of minus 3 plus 1 and then the derivative. For first few examples which we have taken here, it may be a good practice to write it with negative exponents and then get the solution. So we get 2x minus 3 will be 9, right? So plus 9, x to the power of minus 3 minus 1, which is minus 4. And for a constant, the derivative is 0. So, right, so we have here the derivative as 2x plus 9 over x to the power of 4, correct? Question 11 is y equals to x minus 1 whole square. Knowing this power rule, what we should do to apply it effectively, we can expand. We know what is a minus b whole square. So let me write down the formula here. A minus b whole square is a square minus 2ab plus b square. So apply the formula, expand. So we get x squared minus 2 times 1 times x, which is 2x plus 1. And its derivative will be 2x minus 2. Makes sense, right? Correct. So question number 12 and 13, they are similar to the previous question. You need to expand and then find the derivative. So let's do it. So question number 12, we can expand and rewrite this as square of 2x will be 4x squared minus 2ab means 2 times 2x times 3, right? And then we have plus 3 squared, which is 9. So let me rewrite this as 4x squared minus 4 times 3 is 12x plus 9, right? And now we'll write down the derivative as 8x minus 12. Makes sense, right? Applying the power rule. So now you're good at it. Perfect. Now this time, question number 13 is y equals to 2x times x squared minus 3. How will you do it? Apply distributive property, expand and simplify. So 2x times x squared gives you 2x cubed minus 2 times 3 is 6, 6x, and therefore the derivative will be 6x squared minus 6. Clear? Next example, 14. So we have x minus 2 times x plus 1. Let us expand and simplify. We get x squared plus x minus 2x minus 2. That gives you x squared minus x minus 2, and therefore the derivative will be 2x minus 1. Clear? Next one here. Let us expand. X squared plus 2 times x times 1 over x plus 1 over x squared, right? So which could be simplified as x squared plus 2, right? They cancel x and x, plus 1 over x squared, I'm writing as x minus 2. And now the derivative is 2x, that derivative is 0, minus 2x to the power minus 3, or the derivative can be written as 2x minus 2 over x cubed. Makes sense? So that is how we are going to find derivative of this particular function. You see, derivative is also a function. Perfect. We are going to analyze the derivative of the functions in the next video. Perfect. Next set of questions is right there before you. I will now like you to pause and answer these questions. In case you need help, feel free to send an email on the address given. So here, when you expand, what do you get? Well, you could think like 2x cubed divided by x minus 3x divided by x. That helps, right? So we get 2x squared minus 3, and the derivative, therefore, will be 4x. Constant derivative is 0. Similarly, you do the next one. Y can be written as 3x cubed divided by x squared is 3x minus x squared divided by x squared is 1, and this gives you 5 by x squared, right? And the derivative for this will be 3. Derivative for constant is 0, and here, since the power is minus, it will be plus 10 over x cubed. Makes sense, right? So I've written it directly. By this time, you might have get the idea how to do it, right? X to the power of minus 2. So minus and minus makes it plus. 2 times 5 is 10. And minus 2 minus 1 is minus 3. Perfect. So there we go. Question number 18 and 19 for you. Here we have 5a x cubed. Remember, a and b now I'm taking as constants, okay? So a and b are constants. So in this case, apply the power rule. So what do we get? We get y equals to 5 times 3, right? Or you could just expand it, right? So 5 cubed, this is basically 5 cubed, right? Let me rewrite this as 5 cubed, right? Okay, a cubed, x cubed. You see, all those are constants, correct? So the derivative basically is 3 times 5 cubed times a cubed times x squared, right? So x n to the minus 1, right? So you could now write 125 into 3, right? 3 times 5 cubed is 125, a cubed x squared, and that is 3 times 5, 15, 1, 3 times 2, 6, and 1, 7, and then 3, 75 a cubed x squared as the result, right? So that is how you can expand and then write down your result. Question number 19. Y equals to 4 by 3 pi x cubed. Derivative will be 4 by 3 pi, these are constants, and x cube can be written as 3x squared, right? So writing the derivative after that constant becomes sometimes simpler. Now you can simplify cancelling 3's and you get 4 pi x squared, right? Now this is very interesting. You see, 4 by 3 pi r cube is the volume and 4 pi r squared is the surface area. So volume becomes surface area when we take the derivative. Clear? Okay, good observation. So that should help. So try to see what are we getting as our results. Well, in case you want to learn from me, feel free to send the email on the address given. Last two examples, I would like you to pause the video, do them yourself. So first you have to expand, right? So we get what? So y equals to x squared minus bx minus ax plus ab, right? Product and sum, right? So x squared minus. You can write this as b plus a times x plus ab, which is same as x squared minus a plus b x plus ab, and the derivative therefore should be what? Well, the derivative will be 2x minus the coefficient of x, which is a plus b, right? And for ab, it is going to be 0. So you could write this as 2x minus a minus b. Clear? So that is how you get derivative of this expression. Perfect. Let's do the next one. When you expand, you get y equals to a squared x squared plus 2 times abx plus b squared. And therefore, the derivative of this will be 2 times a squared x to ab, right? So that becomes the derivative of this term. So similar expressions are here for you. Now this is for you to practice. I hope the steps are absolutely clear. Feel free to send an email on the address given to learn more and be an expert on any topic, including calculus. So, can you please expand this and then rewrite the expression? Well, if I expand, I get a squared x squared, right? Plus 2 times ab, x and x cancel, plus b squared over x squared. And the derivative will be 2 times a squared x plus that is 0 and x squared is in the denominator and that will make the sign as minus 2, right? B squared over x cubed. Perfect. Right. You may add a step there like we had been doing earlier. So that is also fine. This last one, a minus b whole cube. So we have y equals to, you remember the formula, a minus b whole cube. So it is a cube, right? A square x cube, a cube minus 3a square b, right? Which is a square x square b plus 3ab square, which is axb plus b cube minus b cube, right? So because this is minus. So now the derivative after the expansion becomes 3a square x square. So it should be cube, sorry, a cube x square. And this will be 3 times 2, 6. A square bx, I'm just rearranging it, plus 3ab minus 0. So no need to write that. B cube is a constant. Perfect. So that brings us to the end of this particular series. Here are the last two questions for you. I hope you find it interesting and useful. Feel free to write your comments and share your views in case you want to learn. Visit our website or send an email on globalmathinstitute@gmail.com. Now, these are your test questions. You can expand, simplify, and find the derivative. So, when you expand, you get ax minus 2 times square root of abx, right? And when you square this, you get b. Simple as that. Derivative will be a. And of this, square root abx, x derivative is going to be, this is square root x, right? So let me write this as 2 square root ab, which is constant before x, right? So, and then we are square root of x, which is over 2 square root x, correct? And this derivative of b is constant. So 2 and 2 cancel, and we get this derivative as a minus square root of ab over x. Makes sense? So that is how we are going to find the derivative. Perfect. The last question here, simple as that. We did it earlier. Y equals to a square x square plus 2abx plus b square. B, is a constant, right? So the derivative will be 2a square x plus 2ab, right? So that becomes the derivative for this particular question. So with that, we solve 25 questions, all based on the power rule. So I hope now you have an expertise on using the power rule, which is applied to y equals to ax to the power of n and can be written as n times a times x to the power of n minus 1. Perfect. So we end this video at this stage. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.